Hey, Hunter de Jong here. Let's discuss the electric current of a circuit. Current is the movement of electrical charge throughout a closed circuit. Within conductive elements such as copper or gold wiring, immense numbers of free valence electrons are dislodged from their respective elements and are released into constant motion. However, without an external force, the electron movement is random, such that the sum charge movement is cancelled out. Once an external force, such as a battery, is applied to the circuit, a positive and negative node on either end of the battery creates a potential difference in the circuit. This forces electron movement to become uniform, creating constant movement of charge. The unit of electric current is the ampere, which is defined as the amount of charge flow over time. 1 ampere is equal to 1 coulomb charge over 1 second. That is 6.24 by 10 to the 18 electron charges flowing per second. We can use ammeters to measure the current within a circuit path by connecting its leads in series with the circuit. As electrons are negative charge carriers, once a positive and negative node are created, they will repel from the negative node and flow towards the attractive positive node. The conventional current that scientists use, however, shows the flow in the reverse direction from the positive towards the negative terminal as if the charge carriers were positive. Other than calculating the charge over time, there are two main formulae that we can use to calculate current. The main method for calculating current is Ohm's law, defined as voltage equals current times resistance. This can be rearranged to find that the current is equal to the voltage divided by the resistance. This formula can either be over an entire circuit to find the source current by using the total voltage and total resistance, or the current passing through a component by using the change in voltage over the component and the resistance of that component. The other formula is derived from Watt's law, which defines power equal to voltage times current. Again, this can be rearranged to find that the current is equal to power divided by voltage. A known law that defines current in a circuit is Kochov's current law, which states that the current flowing into a terminal or node is equal to the current flowing out. As such, in a series circuit, the current is constant. However, in a parallel circuit, the current is distributed between subsequent paths depending on the resistance. Current always takes the path of least resistance, so the lower resistive path will have more current pass through it. To calculate the distribution of current between paths, we can use Kochov's current divider law by multiplying the input current by the ratio of the opposite path resistance divided by the sum of the resistance. Finally, depending on the external force acting on a circuit, the current can either be alternating or direct, AC or DC. Within a DC circuit, the current is constant and positive, whereas within an AC circuit, the current magnitude and direction alternates in respect to a sinusoidal wave. That's all for now, guys. See you around.